Hey, welcome everybody. Dr. John Thompson here for Extract Lab, and I'm joined here by Doug Fryer.
Hello.
Hey, today we're going to be talking about a very exciting subject, one of our favorite subjects in all the world, and that is decarboxylation, how to decarb cannabis, about the mechanism for decarboxylation. We're going to get into that.
Yes.
Why you would decarboxylate in the first place, right? Mm-hmm. Here on this first slide, you can see this is a progression of botanical here going all the way over to wonderful white isolate.
Isolate, yep.
And here in between, you can see there's a little bit darker material here. That is basically a decarboxylated biomass. Right. In some cases, you can take your oils and decarboxylate them just by cooking the living daylights out of them.
Put it on a 5-liter Erlenmeyer flask on a hot plate with a stir.
You got it, decarboxylated.
Cook it at 200 degrees C for a couple hours. The smoke comes off and
smoke and
it's
and while stirring, and it gets all dark and black, yep. And
all sorts of oxidation and lovely things happening during the time. So we choose to decarboxylate first before extraction.
Yeah, so we'll get into that. It's going to be a lot of fun. Here is our resources. You guys should take advantage of those. We got our podcasts. We got product tours. We got mini courses. We got guides. We got calculators. We got it all. You just come to our website. We have all kinds. Let's now talk about the decarboxylation mechanism.
Just decarboxylation. The simple process is you add heat to the material and CO2 is evolved.
Exactly.
That is it.
Yep. So you have CBDA or THCA in this case. Yes. Converting to a neutral molecule. And the reason we say it's neutral is because you can see on the slide here, you have this OOH. That's what we call an acidic moiety, right? It under certain pH conditions, if you are under pH 4.5, of course, that's going to be acidified. It's not going to be, it's going to be acidified, meaning that H is going to actually be on there, okay? And it's neutral. But when you go up more, say, to pH 7 or neutral pHs, which you would find in the plant, this would actually be a negative charge on that oxygen. So that means that's an acid.
Yes.
So this is an acidic moiety here. So you can see, look what happens after decarboxylation. It's no longer there.
It absolutely leaves.
Let's just talk about this mechanism. It's pretty simple. You basically have a participation here of this oxygen here. The OH bond is evolved. It comes a double bond here. You can see the double bond here. And then this hydrogen comes out. This is an electrophilic attack.
Substitution. Yes.
Yeah, where the lone pair here is actually being donated to the oxygen. The pair here goes off to this oxygen, makes it a OH, and the CO2 gets evolved. So, boy, you know what? I got to brush up on my organic chemistry. I haven't done that in a long time. But, okay, this is where the organic chemists make fun of us. But at the end of the day, what we have here is the neutral molecule, and then we have CO2 evolved. So it's a chemical conversion of an acidic molecule to a neutral molecule using heat. CO2 is typically evolved in the process, and like you mentioned, obviously water is evolved. Now, as you add heat, 150 degrees Celsius, you have an issue there, right? Because you will have terpenes, right?
Yes, terpenes and thermal breakdown. So the reason we operate under vacuum is to prevent any further oxidation, et cetera, in the system. So working under vacuum, just having oxygen present leads to all sorts of side chain reactions that we don't want to even mess with. So vacuum is the best way to go. In the case of THC, you specifically get CBN formation. And you don't want that for starters.
Not generally,
right.
No,
yeah.
Unless you're trying to make CBN.
Well, unless, yes.
A lot of people actually use this mechanism to make CBN, however. If you are going to do it in the plant, the other way to do it would be an iodine. That's another well-known method. But you also get the terpenes that come off, right?
Yes.
And those will often co-distill with the water. And, that's why we have a product called the terpene trap. The terpene trap is basically it's a condenser. That's all it is. It's a condenser with a big pot on it. So you have your biomass that has 10% water or 5% water, right? And that water is going to come out under this vacuum, okay? Also, is steam distilling off of those terpenes off, and then They're traveling very quickly through the vacuum, which is nice. It's oxygen free essentially. And then it goes and it hits the condenser. It condenses, it turns from the gas to a liquid, and then it starts to drip down, and then you can collect it
in the collection bin and maintaining vac the whole time. Basically getting the CO2 and water and terpenes away from the process as quickly as possible is really what we're doing here with the decarboxylation. By throwing a condenser, you are creating it's not exactly a pressure gradient, but you're providing a hole for the place for the stuff to flow to by throwing the condenser in there.
Right.
Otherwise it would just sit there.
Right.
And hang out and slow the process down. And then the longer it takes, the more degradation you get of your product. And so
it's a problem.
Bigger, better, faster. Everything is about going as fast as you possibly can and get it done so you can go to the next step in process and extract.
Absolutely. Can you do this decarb in the microwave?
It's yes.
Yes, absolutely.
The microwave is awesome, but
well, the microwave, what's wonderful about the microwave is it's going to directly heat the water molecules. It's a rotational energy, so that's how microwaves work. One thing about the microwave, obviously, is you're going to be going up to 100 degrees Celsius, right? Essentially, that's the boiling point of water. Is that enough energy to actually decarboxylate? Well, not really. But there is some amount of decarboxylation that occurs. I mean, you won't have a very good efficiency doing that in a microwave.
Right.
Even
sounds like a great research topic. I should really get into that.
Doug, go get some weed and decarboxylate it in the microwave.
Right, I needed it. We've got one.
And you
in the
need
kitchen.
to test it, of course, afterwards. So you know, we got to figure that out. So, also, how about Instapot decarboxylation? You could do that if you kind of hooked up your Instapot, so that you take the temperature. You would take that, like the temperature, safety mechanisms out. You just snip those out, put the wires back together, plug it into the wall, turn it all the way up, kind of like on a Variac, essentially. It'll get really hot in there. And you could probably decarboxylate in your Instapot. So just in case those of you guys who are looking
in your garage, of course.
In your garage, well, of course, So those of you who don't want to have pristine terpenes come out, which is really what the purpose of the vacuum is, right? The purpose of the vacuum is to prevent oxygen from reacting with the terpenes that are volatile and highly reactive. You're looking to basically preserve those, so that's why we have the vacuum, and also to lower the boiling point of the terpenes and the water, and also improve the whole collection of those volatiles.
Right. The energy of activation to get over the hump to get the CO2 to come off to do the decarboxylation is the same. You're not changing that by putting it under vac, but you're changing everything else around it, to allow it to occur more easily.
Right.
Yep.
So the key to decarbing marijuana or cannabis is really heat and vacuum if you want to preserve the terpenes. If you have a nice, large condenser, you're able to preserve those terpenes. You're really able to do this at scale, which is really nice. I mean, you can do this at the tons per day easily. We have done that before. Yes. Yeah, it's really not hard to do.
A big stirred vacuum mixing chamber.
Right, mixing chamber. Yeah, you typically use big V mixers, and of course you hook them all up. They're customized, but it's a very interesting way to get a very good decarboxylation. Now, a lot of people use decarboxylation ovens, right?
Yes, that's the common way is just
like a vacuum oven or even a non-vacuum oven, right?
And just the open convection ovens.
Yeah.
If you don't use vacuum, you generally want convection to get some air exchange to remove all of the water. It drags things out. Is if you have a closed location, the water is going to prevent your temperature from going up too much. A pot of water boils at 212 and it never gets above 212 until the water's gone. And then it goes up. So having the water hanging around limits how fast the reaction actually takes place.
Yeah.
So getting rid of all the water first, and then you can start decarboxylating.
Thinking about the oven now, the different types of ovens. A lot of people wonder, should I get a non-vacuum oven? Because those are a lot less expensive, right?
Absolutely.
Than a vacuum oven. So why would I spend all the money in a vacuum oven? And is there any mods that I need to do to my vacuum oven to make it better, right? So the answer is yes. So first of all, you should typically avoid the vacuum or the ovens that don't have a vacuum capability. That just doesn't make sense to have those because you're just adding a bunch of oxygen in there. You're cooking in oxygen, right?
Oxidation is a big deal. And then all the other plant matter that you end up extracting, it breaks down into from, being a half a dozen compounds to 30, 40, 50 different things. And you're pulling all this random stuff out when you extract, and it just leads to more headaches downstream. So reducing the oxidation, eliminating it entirely is a big step.
So buy the vacuum oven. I mean, it makes more sense. Think about things like UL. You want to have a UL or CE listed, oven, right? Yep. So sometimes you need to buy those and add those. They're worth their money because oftentimes you'll get it. If you ever scale up your operation, you're going to take a look at that and they're going to say, okay, do you have the UL stamp on it? And then you're not going to be able to use it. Or even CE. If you're in Europe, you have to have CSA. A CE or CSA. Yeah, exactly. So those are some things that you need to be thinking about with your ovens. And then with your traps, what kind of vacuum would you use? Well, we typically use it's like 27 inches of mercury. I think that's the level. That's the maximum level.
A negative 27 inches, if you want to be technical. But it comes out to, if you can get under 100 torr, you're good enough.
I hope that this was helpful for you. We want to provide great information for you guys. A lot of people have been asking us about what is the decarboxylation mechanism and how do you use it? How do you really decarboxylate weed? How do you decarboxylate marijuana? And hopefully this was very informative for you. Thank you so much for all your time, and talk to you later. Goodbye.